In this video, I'm going to talk about concavity and the second derivative test. So this chapter or this section, this topic is on section 3.4 on the book. Okay, so let us consider a graph. This is a graph of the function f of x. Okay, and on this graph you can see that the graph is increasing here, right? Up to 3 it is increasing. You see that up to 3 it is increasing, and then from 3 x equals to 3 to x equals to 8 it is decreasing, right? And from 8 to right side it is increasing again. You see that? So also you can say that if you have a shape of this form, we call concave down. This is concave down. Okay, you can see that concave down between 2 and 5, and after 5 it starts to up, concave up. This shape is the concave up shape. Okay, so increasing and then decreasing and then increasing. So increasing and decreasing will give you concave down, and decreasing and then increasing combination will give concave up. Let us list the interval where it is concave up and concave down. So you can see that the graph is concave up between 5 and 11, right? So 5 and 11, and concave down between 2 and 5. 2 and 5, okay? Because left to 2, it looks like it is concave up again, and similarly right of 11, it looks like it is going to concave down again. But so what we can say is between 2 and 5, it is concave down, and between 5 and 11 it is concave up. Also what you can say, the increasing left of 3 it is increasing, right? And between 3 and 8 it is decreasing, and right of 8 it is increasing. So if the graph is given, then you can say where it is concave up and concave down. But if the graph is not given, then we cannot say like just looking at the question, right? So what we have to do, what we want to do here is we want to use the derivative to check where it is concave up and concave down. In the last video, we checked about how to use the first derivative to find out where the graph is where the graph is increasing or decreasing without drawing the graph. If the first derivative is positive, the graph is increasing, right? If the first derivative is negative, then the graph is decreasing, and so on. Okay, so let us see one more example, and then we will draw the graph of first derivative and the second derivative, and then we will see if we can find anything for the concave up and concave down from using the first derivative and second derivative. Okay, let us see that. So the function is increasing here, right? Left of 2 it is increasing. So let's write down increasing on left of 2, right? X less than 2, right? And decreasing between -2 and 0, right? So let us write this way. Instead of writing less than 2, what I want to write here is I want to write in the interval form. Okay, let us suppose that the graph keeps going in the direction, the same direction on left of that, and then the same direction on the right side too. So what I want to do is I want to write -infinity to -2 is increasing interval. What is another increasing interval is 0 to 2, right? So I want to write 0 to 2. How about the decreasing interval? Decreasing interval is, I can write -2 to 0, -2 to 0. This is one piece, and the other piece decreasing is 2 to infinity, right? Because 2 and right. So this is the decreasing interval. Okay, in the increasing interval, what happens? F prime is positive, right? In the decreasing interval, F prime is negative. Okay, now what we want to do is look at that. At x equals to -2, F prime is 0, right? Here F prime is 0. F prime is 0 at x equals to -2 and positive 2. F prime is 0. Also at 0, F prime is 0, right? Why? Because there is either neither increasing nor decreasing. It is the boundary between increasing and decreasing where F prime is equals to 0. Okay, now let us draw based on this. Also, let us list where it is concave up and concave down. So concave up, where it is concave up, let us make that boundary. So -1 through 1, right? -1 through 1 is concave up, and concave down is 1 is -3 to -1, -3 to -1. This piece is concave down, right? And another piece that is concave down is 1 through 3. 1 through 3. Now, let me tell about something here. Look at these dots. These dots in the first graph are basically the boundary between concave up and concave down. You see that? And this dot is also on the left side, it is concave down, on the right side it is concave up, and this point. So these points are the boundary between concave up and concave down. We call them as point of inflection. So what I want to write is x equals to 2, 5 and 11 are the point of inflection in this case, because they are the boundary between concave up and concave down. Let us list the point of inflection here. Point of inflection. What are the boundary between concave up and down? So we don't know about -3 because we don't know whether it is concave up on the left side, because it keeps going, right? It keeps going like this and it keeps going like that. So what I want to say here is, so it is the point of inflection is -1 is for sure, x equals to -1, because it is the boundary between concave down and concave up, right? And then another one is basically, you know what, for the concave up you can write -1 to 1. For concave down you can say left of -1 is concave down. You can write -infinity here. So you can think as 1 through infinity, because I just added the arrow head on each side. Okay, so I don't need this one, I don't need this dot there. Okay, I don't need this dot and that dot there. Okay, so point of inflection, one point of inflection is -1, the other is +1, right? Why? -1 and +1. Why? Because they are the boundary between concave up and concave down. So from this graph we just listed everything. Okay, now let us draw the derivative of this. How do I draw the derivative? Derivative is decided based on the increasing and decreasing pattern, right? Okay, left of -2 the function is increasing. You see that? The left of -2 it is increasing, meaning that the f prime must be positive there, right? Look at this. On this side f prime is positive, meaning f prime must be above x-axis, but at -2 f prime must be 0. This is the graph of f prime. Okay, at -2 it is 0, and left of -2 it must be positive. Okay, at left of -2 f prime is positive, at -2 f prime is 0, and between -2 and 0 the function is decreasing, right? The function fx is decreasing, so f prime must be negative. Where? Between -2 and 0 it should be negative, and at 0 f prime is 0, right? Let me write this way. Okay, between -2 and 0, right, f prime, this is the graph of f prime. F prime is negative because in this case, in this piece f prime is negative because it is decreasing. Look at that. And at 0 f prime is 0. Okay, now between 0 and 2 f is increasing, right? F is increasing, so f prime must be positive between 0 and 2, and at 2 f prime must be 0 again. Did you see that? And again at the right side of 2 the function is decreasing, so the f prime must be negative. Look at that. So this is how I draw the graph of f prime of x. You can see that, look at -2 f prime is 0, right? F prime is 0. See, f prime is 0 because f prime is crossing that horizontal axis, right? And then at 0 f prime is 0, at 2 f prime is 0 as well. That's why we cross those. Now so this is the graph of f prime. I want to draw the graph of the derivative of f prime, that is f double prime. I want to draw the graph of this one too. Now to draw the graph, so let's talk about f prime. What is happening on the f prime? Let us list that. For f prime, increasing in the interval -1 through +1, right? -1 through +1, and then decreasing in the interval. Where it is decreasing is -infinity to -1, because it is decreasing in that piece. -infinity to -1, right? And then 1 through +infinity. 1 through positive infinity. Now if you want to draw the graph of this f prime, the graph of the derivative of f prime, that is f double prime, if you want to know the graph of f double prime, it depends on the graph of f prime. It is decreasing between -1, left of -1, right? Left of -1, it is decreasing. That's why the graph will look like this, right? It is below x-axis, right? And between -1 and +1, it is increasing, meaning it must be positive. And at -1, the f double prime must be 0. And at +1, because this one will have this point and that point will have the derivative of that 0, right? So f double prime will be 0, f double prime will be 0. Here f double prime must be negative, right? On this piece f double prime must be negative as well. On this middle piece f double prime must be positive. Now on the right of 1, it is decreasing. The first derivative is decreasing, so second derivative must be negative, like that. Okay, so what can you say here is left of -1, f double prime is negative. You see that? So in -infinity to -1, f double prime is negative, right? And what is the another interval where f double prime is negative? 1 through infinity also f double prime is negative, right? And which interval f double prime is positive? F double prime is positive in the interval -1 through 1. It is positive. F double prime is positive. Look at this. For the concave op, let us relate this. Let us relate this information, okay, with this information that we got. Let us relate those. Concave down, where? -infinity to -1 and 1 through infinity. Look at that. -infinity, -1 and 1 through infinity, it is concave down. Where it is concave down? The region where the second derivative is negative. If the second derivative is negative, then the function is, the graph is concave down. If the second derivative is negative, then the graph is concave down in the same region. Also, look at this one. At -1 through +1, the second derivative is positive. At -1 through +1, it is concave up. If the function is concave up in a region, in an interval, then the second derivative is positive. So second derivative positive means the graph is concave up. Second derivative negative means the graph is concave down. Also, you can tell about the local max and local mean here, right? Whenever it is concave down, what happens? So this is basically concave down, right? So this one is concave down. And this region is concave up, okay? So whenever there is concave down, the second derivative will be negative, meaning there is a chance of local maxima. When the second derivative is positive between -1 and 1, it is concave up, there is a chance of local minima, okay? We'll write the details later, but I just wanted to show here. Second derivative is negative, left of -1 and right of +1, that means on those intervals, okay? And when I go to the graph, I see that in those intervals, it is concave down. So second derivative negative means it is concave down. Second derivative positive means it is concave up. That's how I wanted to relate.